Good morning, everyone. So today we are going to discuss a problem on futures and options. The data is given here. Companies, a generation company is positioned for 11th June 10 a.m. to 11 a.m. is given. Um, there are many transactions. Some of them are physical transactions and some are financial transactions. So the first transaction is a long-term contract for the purchase of 600 megawatts during peak hours at a price of $20 per megawatt hour. That means, as it is a purchase contract, the company has an expense of 600 into 20. Then and this is a physical contract. Okay, the company is delivering energy physically. Now, the second contract is long-term contract for the purchase of 400 megawatts during off-peak hours at a price of $16 per megawatt hour. Then the third one, a long-term contract with a major industrial use for the sale of 50 megawatts at a flat rate of $19 per megawatt hour. Then the remaining customers purchase their electricity at a tariff of $21.75 per megawatt hour. Then in the financial market or in the derivative market, the company has the following positions: a future contract for the sale of 200 megawatt hours at $21 per megawatt hour. Then another future contract for the purchase of 100 megawatt hour at $22 per megawatt hour. Then a call option for 150 megawatt hour at an exercise price of $20.5 per megawatt hour. Then a put option for 200 megawatt hour at an exercise price of $23.5 per megawatt hour. Then another call option for 300 megawatt hour at an exercise price of $24 per megawatt hour. It is also given that the option fee for all options, that is the premium for option contract, is $1 per megawatt hours. $1 per megawatt hour. The peak hours are defined as the hours between 8 a.m. and 8 p.m. The positions which we have seen here is for 10 a.m. to 11 a.m. So this comes under peak hours. Then the outcome for 11th June between 10 a.m. and 11 a.m. is as follows. The spot price is set at $21.5 per megawatt hour. Then the total load of the company is 1,200 megawatts. That is for physical transaction. The total load demand to be met by the company is 1,200 megawatts, including the industrial customer, um, which involves a long-term contract, which is already mentioned in the question. Then the power plant produces 300 megawatt hour at an average cost of $21.25 per megawatt hour. That means for self-production, self-generation, it has um, an average production cost of $21.25 per megawatt hour. Now, the question has two parts. The first one is, assume that all imbalances are settled at the spot market. Calculate the profit and loss made by the company during that hour. That hour in the sense 10 a.m. to 11 a.m. on that particular date. So now we move on to the okay. 1 minute. Take the solution part. Okay. Okay. We move on to the physical transactions first. So the total profit of the company is the sum of profit from physical transactions and the profit from financial transactions. So first we'll see what are the physical transactions and the revenue and expense involved in the physical transaction. So the company has a long-term contract for sale of electricity for industrial use. 50 megawatts is the quantity and $19 per megawatt hour is the rate. So this is the revenue for the company, 50 into 19, which is equal to $950 per hour. That, I mean, this hour is 10 a.m. to 11 a.m. Okay. Now, 1,200 megawatts is the total load of the company is given. The remaining load after sale for the industrial use. What was the sale for the industrial use? 50 megawatts is sold for industrial use in a long-term contract. So the remaining load is 1,150. The total load is 1,200. So this should be met at a tariff $21.75 per megawatt hour. It is given in the question that remaining load is met at the tariff rate of $21.75 per megawatt hour. So for this amount of power, 1150 megawatts at $21.75 per megawatt hour, this is the revenue. 25,012.5. 25012.5 is the dollars per hour is the revenue. So there are two parts for the revenue in the physical transactions. One is R1 from the long-term contract, and the second one is R2 from this one, the consumer contract. It's not a contract. Consumers purchase electricity at this particular tariff. Now the total demand is met. 1,150 plus 50 is 1,200. So the total revenue is now $25,962.5 per hour. We take the sum of these two revenues, then we get the total revenue. Now the company has to bear the expense. What is the expense of the company? The company has to bear the expense for facilitating this energy delivery, right? That means it has to find this 1,200 megawatts to be to meet the load. So for that, three parts of expenses are there. The first one is it has a long-term contract for purchase of electricity of 600 megawatts at $20 per megawatt hour. So the total expense for this transaction is 12,000. For this long-term contract is 12,000. Then self-generation is 300 megawatt hours, and the average production cost is $21.25 per megawatt hour. So here the expense for production or cost of production is $6,375. Now, what is the remaining energy that has to be facilitated for meeting the load? The total is 1,200. 300 is self-generated, and 600 is from a long-term contract. So 900 is already filled. Now 300 more. Now it is given in the question that all imbalances are settled at spot market. So the spot price is given as 21.5. So the remaining power is purchased from the spot market. So that expense is 300 into 21.5, which is equal to $6,450. So now the total expense from physical transactions is E1 plus E2 plus E3, which is equal to 12,000 plus 6,375 plus 6,450 equals $24,825 per hour. So this is the total expense. Now to find the total profit from physical transactions, R1 plus R2 is the total revenue minus E1 plus E2 plus E3 is the total expense, which gives 1137.5. Now we move on to financial market transactions. In the financial market transaction, the company has a future contract for the sale of 200 megawatt hours at $21 per megawatt hour. That means the strike price here is $21 per megawatt hour, but we know that the spot price is 21.5, and this is a sale. This is a contract for sale. So definitely the company will have a loss, right? And what is the loss of the company? 21 is the strike price, 21.5 is the spot price. So 21 minus 21.5, and the quantity in the contract, quantity quoted in the contract is 20 megawatt hours. So minus $100 is the gain. That means $100 is a loss. Okay, for this particular financial transaction. Now, another future contract for the purchase of 100 megawatt hours at $22 per megawatt hour. This is the strike price, but you know that the spot price is 21.5. So again, the company has a loss of $50 because the amount is 100. So strike price, spot price minus strike price into 100 gives minus $50. That is $50 loss. Then the third one is a call option for 150 megawatt hour at exercise price of 20.5 and the premium of 1. It is given in the question that for all option contracts, the option contract fee is $1 per megawatt hour, or the option premium is $1 per megawatt hour. So there is an upfront cost while getting into the agreement itself. Getting into the option contract itself, which is equal to $1 per megawatt hour into whatever is the amount quoted. So here the quantity quoted. The quantity here is 150 megawatt hour. So there is an upfront cost for the company, which is 1 into 150 megawatt hours. Now the spot price is 21.5 and the strike price is 20.5. So here the company is in no profit no loss because there is an upfront cost dollar per megawatt hour. So the total expense for the company is 21.5, and here the spot price is 21.5. Now 21.5 minus 21.5 into 150 megawatt hour is a quantity, which is $0. That means $0. That means it's a no profit no loss position for the company. Now another put option for 200 megawatt hour at 23.5 and the same premium of $1 per megawatt hour. Here we know that the exercise price is 23.5, right? But the spot price is 21.5. And what is put option? Put option is, call option is for buy and put option is for sale. So sale at 23.5, the comparison is sale at 23.5 and sale at 21.5. So sale at 23.5 is better, right? So the exercise price is better, but there is an upfront cost on premium of 1. So 23.5 minus 1 minus 21.5 into 200 gives $200. So this is a gain for the company. Now another call option for 300 megawatt hour at $24 per megawatt hour. Again, call option means it's buying, it's purchase contract for purchase. So purchase at $24 per megawatt hour as per the exercise price, and purchase at 21.5. So purchase at 21.5 is better, right? So basically the company has a loss of $300 because the spot price is less, but there is a cost on premium. So the problem here is the company is not going to exercise this option because the spot price is less than exercise price plus premium, right? Spot price is 21.5, exercise price is 24. 24 plus 1 is 25. So 21.5 is less than 25, and the company is not going to exercise this contract. You know that in an option contract, the holder has a choice to exercise it or not. Here they are not going to exercise it, but there is a loss in premium. There is an upfront cost for premium, which is $1 into 300, which is $300. This is a loss, so minus $300. Now we are going to find the total profit from the financial market. Here we have listed out all the gains and losses for the company's position in the financial market. So the total is now minus $250. So that's a loss. Of course, this profit is negative, so it's a loss. Now profit from physical market equals $1137.5, which is already found. Now the total profit is the profit from physical market plus the profit from financial market, which is $1137.5 minus $250, which is equal to $887.5. So this is how we solve the problem on physical and financial transactions. If multiple transactions are involved in physical and financial market in a particular time period, then how to find the net profit and loss for the company. Now, there is a second part for this question as homework. What value of the spot market price would reduce the profit or loss of the company to 0? Would this change in spot price affect any of the option contracts? Please do this as homework. Thank you.